Algebra 2, we are in Chapter 6, Section 2 with the warm-ups. I did this warm-up before recording it because it's long. Binomial theorem to expand this binomial. Okay, remember we can rewrite this binomial into x plus negative 3 in parentheses raised to the fifth. First thing I did was right here. I needed my fifth row of Pascal's triangle because these are the coefficients that I use for my expansion. Right? Then we take the first term to the fifth power, second term to the 0 power. We go down by 1, and we go up by 1. Right? Rewrite it. We have our answer. Okay, these two purely calculator, right? I typed them in, pressed enter, and life is good. All right. Another review. A coin tossed 5 times. What is the probability of getting exactly 4 heads? Okay, heads, 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 heads. Not heads. Still, right? We get our answer. Moving on to the new material. A random variable is a variable whose value is determined by the outcomes of a random event. For example, when you roll a 6-sided die, you can define a random variable x that represents the numbers showing on the die. So the possibility of values of x are 1, 2, 3, 4, 5, and 6. Those are the things, when you roll a die, you can get those 6 answers. For every random variable, a probability distribution can be defined. This is what we're doing right now. So if we look at that 6-sided die, a probability distribution is a function that gives the probability of each possible value of a random variable. The sum of all the probabilities in a probability distribution must equal 1. So probability of rolling a 1 is 1 out of 6 sides. Probability of rolling a 2, etc. Probability of rolling a 4 is 1 out of 6 sides. Rolling a 5, 1 out of 6. Rolling a 6, 1 out of 6. Now remember, if you added all these up, the sum of all of those is going to equal a 1. They have to be. Must equal 1. So let's try our first one. Let x be a random variable that represents the sum when 2 6-sided dice are rolled. Make a table and a histogram showing the probability distribution for x. I left the solution in here from the book because it was just a lot of writing and not mind-blowing. So the possible values of x are the integers from 2 to 12. That means we're adding things up. We said the sum when 2 6-sided dice are rolled. So you roll 1, you can get a dot and a dot. So that's going to be our 2. And then all the way up to 12. So if we roll 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, then we get a 12. And the possible answers are everywhere between 2 and 12. The table shows how many outcomes of rolling 2 dice produce each value of x. Divide the number of outcomes for x by 36 to find the function p of x. So we have our sum of 2. That happens all of 1 time, so that's 1 over 36. Possible outcome of 3 happens 2 different times. That's 1 over 18, which is 2 over 36. Same thing. Okay, outcome of 4, which is going to be a die with 2, a dot and a dot. that one. Sorry, this should be 3. Okay, that's how we get 3 different ways to make 4, which is 3 over 36, or 1/12. Okay, I can do this all the way between 2 and 12, different ways to make the sum of the numbers. We always get, this one, 5 over 36. This is 6 over 36. It's just a reduced fraction. Now, if you change all of these into decimals, it's going to be easier to graph your histogram because fractions can be a little bit difficult. So if we put the decimals here, our histogram has to include everywhere from 2 to 12, which is your sum of 2 dice, and your probability, and it's just a bar graph. You see that 7 is the most common, and we know that if we play any dice game, that 7 is your most common roll. Also notice that 0 and 1 are impossible, and anything greater than 12 is impossible. Now use the probability distribution in example 1 to answer each question. What is the most likely sum when rolling 2 6-sided dice? Well, I just talked about that. It is, in fact, 7. It's the highest bar in your bar graph. What is the probability that the sum of the 2 dice is at least 10? So we want the probability that x is greater than or equal to 10, which means I want the probability that x is equal to 10 plus equal to 12, 11 plus equal to 12. So I go back to that chart. I can get all of those answers. So 10 was 1/12. 11 was 1/18. And 12 was 1/36. I add all of those together, and I get 6 over 36, which reduces to 1/6, which the decimals are just more useful in my mind. That's your probability the sum of the 2 dice is at least 10. Ooh, a tetrahedral die has 4 sides numbered 1 through 4. Let x be a random variable that represents the sum when 2 such die are rolled. So if I got numbers 1 through 4, that means the sum of those are going to be between 2 and 8, which is what I wrote right here to get started. So the total answers I can get are 16. 16 different ways. So to get 2, I've got 2 different ways. No, sorry, 2 is just 1, which is 2 dots. 3, I can make 2 different ways. 4, I can get 2 plus 2, or 1 plus 3, backwards and forwards. So 3. 5, I've got 1 and 4, 4 and 1, 2 and 3, 3 and 2. 6, 1 and 5. Nope, can't do a 5, right? Because it's a 4-sided die. So 6 is going to be 2 and 4, or 4 and 2. I think that's it. Yeah. Oh, what am I missing with 6? Oh, 3 and 3. That's going to give me 3 over 7. Just one way, actually 2 ways. I can get 3 and 4, and 4 and 3. over 16. There we go. Okay, those can all be reduced into decimals and reduced fractions. And you notice here I put the decimals and the reduced fractions. So I'm going to get a thicker highlighter. Okay. My answer for 2 is 1 over 16. My answer for 3 was 1 over 8. Four was 3 over 16. See, the histograms aren't hard. 1/4. 3 over 16 for 6. One over 8. Very uniform histogram, isn't it? Very symmetrical. Cool. A tetrahedral die has 4 sides. Yes, yes, yes. What is the most likely sum when rolling the 2 dice? Okay. Read the table. The most likely sum was 5. And then what is the probability that the sum of the dice is at most 3? That means we want the probability where x is less than or equal to 3. So I'm going to do the probability of x equals 3 plus the probability of x equals 2. Go back to the table. I have 1/8 plus 1/16, which gives me 3/16, which you can put into a decimal if you have your calculator handy. All right, moving on. Binomial distributions. One type of probability distribution is a binomial distribution. A binomial distribution shows the probabilities of the outcomes of a binomial experiment. What is a binomial experiment, you may ask? Well, a binomial experiment meets the following conditions. There are n independent trials. Each trial has only 2 possible outcomes, success and failure. That's binomial, 2. Okay, 2 outcomes. The probability of success is the same for each trial. This probability is denoted by p. The probability of failure is 1 minus p. So I've got p and 1 minus p. And if you add those up, you get 1. For binomial experiment, the probability of exactly k successes and n trials is n ck, p to the k, 1 minus p to the n minus k. And that's crazy, but our first example, you'll be like, oh yeah, I get it, and this is awful. Not awful, really, just tedious, very tedious. All right, so this right here is what you want to remember. If you remember, we had n independent trials, right? And then we've got these add to 1, so success and failure. All right, according to a survey, about 41% of U.S. households have a soccer ball. Suppose you ask 6 randomly chosen U.S. households whether they have a soccer ball. Draw a histogram of the binomial distribution for your survey. Okay, there are 2 possibilities. Soccer ball, no soccer ball. Okay, soccer ball, no soccer ball. So these are the 2 outcomes, success and failure. Okay, we surveyed 6, the probability random selected is how each house, House, has a soccer ball. p equals 0.41. 1 minus p equals 0.59. And then we surveyed 6 households. So n equals 6. So next page is like, yeah, wow. That's my open, like, surprised look face. Yep, here we go. So pay attention. It's not hard, it's just tedious. So I've got 0 to 6. All right? Because we surveyed 6 households. Or combinations. Okay, 6C0, 6C1, 2, 3, 4, 5, and 6, right? We have our outcome is positive to the 0. Our outcome is a failure to the 6. We go up by 1. We go down by 1. And we get our answer. Okay? Now, I'm going to show you my graphing calculator because I actually figured out a way to do this with our tables. Remember, we liked using our tables. In y1 equals, I typed in 6 NCR x times positive outcome to the x times negative outcome to the negative x plus 6. Okay, I know negative 0 doesn't make sense, but if I go to my table, I will see all of the results for this. And our table goes, I can start from x equals 0, x equals 1, etc. Right? I'm going to grab a new page and take a picture of this and show you. Now, notice here, I went to y equals, and I typed in exactly what was on the last page. Okay, you can't see it all here, but it's in there. Okay, let me show you the results. I'm going to go to the table, which I hit the second button, which should be right here, and table, which is right there. All right, if you go back to the previous slide, these are all of the solutions. When x equals 0, x equals 1, 2, 3, 4, 5 to 6. Okay, way easier than typing all of those, right? It was quite an easier solution. Okay. I think that's it. Okay, we can draw our histogram for 0 through 6. Let's see, for a 0 it was about 0.05. 1 was less than 0.2. 2 was your biggest, above 0.3. 3, a little bit shorter. 4 was just at 0.15. You'll have notebook paper, so it'll be a little bit easier for you. 5 was about the same as 0, and 6 was almost nothing. Okay, there's your histogram. What's the most likely outcome? If you read the tallest histogram, it was 2. And then the probability that at most 2 households have a soccer ball. That is the probability that k was less than or equal to 2. So we do the probability of k is equal to 2, 1, and 0. So I get reading my chart, okay, add all of those together and I get 0.524, which is about 52. I don't know why I said 2, wrote 5. 52%. Oh, oops. Okay, in Sweden, 61% of households have a soccer ball. Suppose you ask 6 randomly chosen Swedish households whether they have a soccer ball. Okay, draw a histogram is what the question. I didn't write it down, sorry. This is number 3. Let's draw a histogram showing the binomial distribution. That's what we're supposed to do, which means we need to work through this. Okay, it's the same as the last problem, except I get 0.61 to the 0 times 0.29 to the 1. That's for k equals 0, etc., etc. I'm going to put it into my calculator real quick. I'm going to ask you to practice that too, and I'm going to put it on a new page to show you. Okay, my first mistake was I gave you the wrong p's because I can't add and subtract. So what I'm going to put in my calculator is going to look like this. 6 to x, 0.61 to x, 0.39 to the negative x plus 6. And then I can look at my table and see the distribution. Now remember, I went here and put in this equation. Then I hit second table and I got these answers. I can graph that into a histogram. And that would show my binomial distribution for my survey. Now this question, sorry, for some reason I deleted the questions. What's the most likely outcome of your survey? That would be the one with the highest number, which if you go back to my calculator screenshot, it is a 4. Okay, if I had graphed my histogram, it would have been the highest bar. And then what's the probability that at most 2 households you survey have a soccer ball? So we want the probability where k is at most 2. We're going to do the probability where k equals 2, probability k equals 1, probability k equals 0. If I go to that calculator screenshot, I've got 0.129 plus 0.0330 plus 0.004. Do some addition. I have 0.166 or 16.6%. Okay, symmetric and skewed distribution. Suppose a probability distribution is represented by a histogram. The distribution is symmetric if you can draw a vertical line that divides the histogram into 2 parts that are mirror images. A distribution is not symmetric, it's called skewed. If we have bar graph, okay, symmetric, because I can draw a mound over it. It's very even left and right. What this is saying is I can draw a line through the middle and it's a mirror image of each side. That says mirror. Okay, it's skewed if I can't do that. I draw a mound, I can't draw a line through the middle, and left and right are the same. Okay, skewed. Describe the shape of the binomial distribution that shows the probability of exactly k successes in 8 trials if p equals 0.5 or p equals 0.9. Sorry. I've got 8 trials. Okay, I know this is where we're totally doing 0.5 to the 6 times 0.5 to the 0. That's a 0. Okay, I'm not going to calculate each one of those. I'm going to put it in my calculator and look at the answer. I'll be right back. Before I'm right back, I see a mistake. This should be 8, and that should be 8. Now I'll be right back. There's my data. Make a histogram. We would see that for k equals 8 is the exact same as k equals 0. Okay, k equals 7 is the same as k equals 1, 6, 2, right? Etc., etc. So if I were to draw a histogram, I'd get a very symmetrical histogram. My highest point is going to be 4, and it mirrors down and up from 4. For p equals 0.09, I'm going to change my y equals 8 to 0. Oh, not 0.09, 0.9. 0.9 to the 8th, 0.1 to the 0. My calculator is actually going to say y equals 8cx, 0.9. I apologize, I have these backwards. That would be 0, and that would be 8. So I'd have 0.9 to the x, and 0.1 negative x plus 8. I don't know why I wrote 0 again. Negative x plus 8. That's what I would type into my calculator, and I would see the data. So if we look here, our data is not symmetrical. E to the negative 8 means 10 to the negative 8. So this is 1 times 10 to the negative 8 is my 0. And my 8 is 0.4. Okay, this is our highest number. Next highest, and it gets smaller. So our histogram would look more like tall, okay? That would be our histogram, where 8 is the biggest and 0 is the smallest. So it's skewed because it's not symmetrical. All right, a binomial experiment consists of 5 trials. Probability P successes in each trial. Describe the shape of the binomial distribution that shows the probability of K successes if P equals 0.4 and P equals 0.5. So we've got 5 trials. So on my calculator, I would write 5cx, and the first what I'm going to do is 0.4 to the x and 0.6 to the negative x plus 6. Okay, I know this one is going to be skewed. And then that's for A. For B, I would type in 5cx, 0.5 to the x, 0.5 to the negative x plus 6. Oh, I'm so sorry. 5 trials. Oh, you guys have to get so frustrated with me sometimes. That's a 5. That's a 5. Okay, 5 trials. Sorry about that. And this one is going to be symmetrical. Hey, we made it to the daily homework quiz. There's your answer. And there's your answer. Cool.